Hey everyone, Terry Vincent here with IP Expert, welcoming everyone to our conversations about DMVPN and the technologies that actually grew to become DMVPN. It may come as a surprise to a lot of you, but DMVPN isn't technically a protocol. It's an umbrella of different protocols that we're going to walk through and we're going to discuss step by step until we actually build this concept of dynamic multi-point VPNs that's going to allow us to be able to connect remote offices via our internal infrastructure or, if necessary, via the internet. So let's take a look at what we're going to be dealing with here. What we see here is a topology that's going to outline the devices that we're going to be interconnecting. Right now, very quickly, all I want to do is I'm going to bring up a console session. I'm going to walk through the topology that we currently have configured in all the protocols that we have running. At the end of the day, what we're going to find is this. We have R3, which is going to be acting like the service provider cloud. Now, the service provider cloud is merely here for the purposes of giving us reachability between R2, R5, 4, and 6. Now, what we're going to do is initially what we're going to focus on is the fact that inside of this network, I am running EIGRP. Now, EIGRP is running simply so that I can get reachability information so that my spokes can actually communicate to the hub. That's all it is. We could have just as easily run it on an individual Ethernet segment and not had to have any type of routing protocol to make this function, but I thought that it would be a better example for us to be able to have R3 in the middle, because later on in our conversations, possibly in the next set of presentations, we're going to be talking about how we would work with DMVPN in environments that may be VRF aware or VRF peered to, say, a service provider device like R3. Now, what we want to do is let's explore this at the configuration or at the console. On R3, all I'm going to do is I'm going to type show IP EIGRP neighbors. And what we're going to see is I have a peering relationship, and that peering relationship is between each of the devices that I discussed. We have R2, which has an IP address of 23.2. One second, guys, I'm going to let some more people in the class. Now, when we look at this, what we see here is that these devices are going to be interconnected using AS1000. So I'll go ahead and write that in, AS1000. Now, when we look at how this is connected, I can see I'm connected via this configuration. Notice I have the connection between 2 and 3, the connection between 3 and 4, 3 and 5, 3 and 6. And this is going to, the last digit in here with regard to the 4th octet tells me which device I'm connected to. Now, the main idea in doing this, again, is just simply so that I can resolve reachability between all of my devices. So from R2, which is going to be my hub in this configuration, I want to make certain that I can reach the individual prefixes on each of these interfaces. And that's what we need to verify in order to make certain that we have all of the proper reachability to bring up DMVPNs or even just regular GRE tunnels. So what I'll do is I'm going to cut over to R2, and I'm going to say ping 183.1 dot, let's see here, what do I have? Show IP interface brief, E assigned. Okay, so what I want to do is I want to ping 183.1.34.4. That's going to be this connection up here to R4. Make sure I have reachability. So we know we're good to go here. All right, bringing the rest of the conversation down from R2, let's see if we can ping R6. That would be ping 183.1.36.6, and we have reachability. Let's ping 35.5. And as we see, we have everything that we need in this topology to ensure that we can do our base configuration. Now, this first introduction isn't really about DMVPN. It's going to be about GRE, which is going to be generic router encapsulation. Now, GRE was a tool that was made available to us to build site-to-site VLANs a long, long time ago, and it also gives us the capability of being able to connect and fix problems. I mean, one of the things that we talked about in our conversations with regard to OSPF is the fact that we can use the idea of GRE tunnels to repair things like discontiguous area zeros in situations where we don't have the capability of using something like a virtual link. Now, what we want to also point out here is in the confines of the way we have our system set up, we are not currently running any routing protocols between these devices. So nothing between 4 and 7, 6 and 9, and 1 and 2 and 8 and 5. So we're not running any routing protocol right now. Now when the time comes, what we're going to do is we are going to light up OSPF. And what we're going to do is we're going to run OSPF across our tunnels. But what we need to focus on right now is taking a look at what happens when I want to create a tunnel between these devices such that R2 is my hub. Now what I'm talking about right now is regular GRE tunnels. Now when we set up a GRE tunnel, nothing's changed from our conversations or any conversations that we may have had with regard to learning in version 4. What we need to really focus on here is the fact that these are going to be point-to-point connections, and each connection is going to have a different IP address subnet. So when we start building this, we're going to see the fact that it can be very time-consuming putting this together, and it doesn't offer the capability of what dynamic multi-point VPN gives us with regard to having this ability to be able to create things in a dynamic nature. Now, looking at what we have here, all I want to do is I'm going to go to R2 and I'm going to build an individual tunnel between R2 and R4. So from R2, what I'll do, let me go ahead and get my console up and running. Config T. I'm going to create an interface that's a tunnel interface that's going to be interface 24. I'm going to give it an IP address of 1.10.20. Let's no, we don't want to do that. Let's see, IP address 24.24.24.2. Now, the thing I want to point out here is notice my state changed to down on this tunnel interface, interface tunnel 24. Now, we don't have anything configured here with regard to, first of all, what type of tunnel it is. So I can come in here and I can say tunnel mode, but what we need to recognize here is this is just a straight GRE tunnel. And GRE tunnels is the default operational mode of this configuration. So if I don't put anything else in here, simply by typing interface tunnel, what happens? I have a regular GRE tunnel. Now we'll look at how to manipulate that later, but the main goal here is just to recognize that that capability is already there. Now what we want to specify here is where are we going to source the tunnel? And what I'm going to do is I'm going to say I want to source the tunnel off of, let's see, serial 20. Do show IP interface brief exclude assigned addresses 20. So that's going to be the one pointing to R3. Now where is the destination? Well, the tunnel destination is going to be going to the interface on R4. So what we'll do is we'll say the tunnel destination is going to be 183.134.4. Now what we're going to see here is notice that it changed to up. Now this is kind of misleading because we haven't done any configuration on the other end, and I just simply want to point this out to you that this status right here of being up and operational is not necessarily indicative of the fact that we have a functioning link between devices. But it will come up by default when we do the configuration on individual connections. So what we need to do is go to the other side on R4 and actually do the marrying config. So on R4, interface tunnel 24, IP address 24.24.24.4. Let's make sure I use the right IP address here. Just one moment. Yeah, I did. So 4/24 tunnel source S20 tunnel destination 183.123.2. Now again, notice my state changed to up. Let's take a look at the interface. Do show IP interface brief E assigned. And what we see here is I have tunnel 24 up and working. Now let's go ahead and annotate the IP addresses that we've used. Here we said that the interface in question was going to be tunnel 24. And we gave it the IP address of 24.24.24.0/24, where this is .2, this one is .4. Now let's see if we actually have reachability in this configuration. So what we'll do is from R4, let's see if we can't ping. So ping 24.24.24.2. And we have reachability. Now the thing that I want to point out here is that notice if I trace route this, and I trace route it to 24.24.24.2, notice it's going direct. Now, the question is how is it going direct if it's traversing the physical connectivity between R2, R4, and R3? Well, because it is exactly what it purports to be. It's a tunnel. Now, the thing is as you can see, we have to make the marrying configurations on both sides of the devices in order to bring up these tunnels. Now, this definitely makes certain to highlight the issue that this is not going to be very scalable. So what I want to do is I'm going to finish the configuration, bring up 3 individual tunnels, and then we're going to make certain that we have the reachability. And then what we're going to do is we're going to talk about another feature that we have available to us called Next Hop Resolution Protocol, because it's going to be GRE, multi-point GRE, and Next Hop Resolution Protocol working together that give us this concept of DMVPNs. So let's go ahead and just do the rest of the config. So I'll go ahead and set it up on R2, do show run, section router, section, we'll do this, do show run, interface, tunnel 24. So interface tunnel, see this one will be 26, so it's going between R2 and R6. IP address 26.26.26.2/24. And we'll say tunnel source serial 20. Tunnel destination is going to be R6, so it's going to be 131.36.6. Go over to R6 and do the matching config. 26, IP address 26.26.26.6/24. Tunnel source, serial 20. Tunnel destination is going to be 183.1.30 or 23.3. And hopefully it should come up. Do show IP interface brief. Exclude assigned addresses. And we see we have the tunnel with an IP address assigned. Let's see if we can ping it. Do ping 26.26.26.2. And we don't have reachability, so let's see what I did here. 26.26.26.2. Do show run, interface, tunnel 26. 36.6. Show run, interface, tunnel 26. Ping 26.26.26.2. Tunnel source, tunnel destination 183.1.36.6. Tunnel 26. Source from, tunnel destination's wrong. Let's see here. Trying to take shortcuts. Tunnel 26. Tunnel destination 183.1.23.2. Sorry about that. Show IP interface brief, exclude assigned. Ping 26.26.26.6. There we go. Let's get the last one up and running. Tunnel 25. IP address 25.25.25.2/24. Tunnel source serial 20. Tunnel destination, it's going to be 183.1.35.5. Do the marrying config on 5. (25, 25, 25, 5). Destination is 183.123.2. Tunnel source is going to be serial 20. Ping 25.25.25.2. Now, as we can see, we've brought up 3 of these tunnels, but the idea here is, as you saw, what a typographical error can do, the configuration issues on setting this up on both the hub and on the individual spokes. And what ended up happening was that the determination was made that they wanted to be able to try to streamline this process. And streamlining the process is going to introduce 2 of the basic concepts we're going to cover in the next video, and that's going to be NHRP and multi-point GRE. So with that being said, what I'm going to do is I'm going to wrap up here, and I'll see you guys in the next portion of the presentation.